Welcome back, welcome back, welcome back. I've got the party hat on, so what does that mean? It means it's our last video for physics, our last talking video. The last video will be a calculator one, and the calculator can't wear the party hat. So we did it. We made it through the year of physics, and we're going to end today talking about magnets and magnetic fields. So this is physics chapter 24, because remember the last bits are more advanced, and then it does chemistry. So we're not going to bother with that stuff. But you are welcome to. There are videos all over YouTube explaining it if you want to keep going. So don't let me stop you. And one of the ones I would recommend is Peterson Science. That's a teacher who teaches in the same county I do, and he teaches AP and honors. And he has chemistry videos, but I think he has physics too. He teaches at the magnet school. But look for somebody like that, someone who's a high school teacher who teaches AP or honors, and you can find more videos on all of this, I promise. And then just read the book and you can do it. But this is where we're stopping, because we have done what we did last year and the year before in physics, and that just seems like a good part. The students I know who I've taught, who did my physics class and then went on to college, got A's with no problem, so they had learned enough in high school that they were prepared for college. My son Eli, I think, ended up with like 100 in physics, and he taught his brother. His brother had not had me for physics. I didn't do so good with the first kid. Homeschool moms get better the more they do it. By the last one, we've got it down, but by the first one, didn't do as good. I trusted too much in other people and didn't teach them as much myself. And so by the next couple who came along, I taught them all of their math and all of their science, just like you can get from me. And they have done great. Just anyway, so the middle kid taught his older brother physics when his older brother was in college physics, and he was still in high school physics, and his older brother got an A in physics too. So see, it's all good. All right, so what we're going to talk about is magnets, and I have a bit of a confession to make. I teach at public school, and I used to just teach homeschool, but before that I taught public school, so it's sort of like back and forth. And I have been taking all of my science supply stuff to public school, because that's where I'm teaching now, and I've taken all my magnets to school. And in fact, one of my kids was saying, "Mom, you took every magnet to school." I was like, because they needed one to get something that they had dropped out of a tight place. I was like, yes, I did, because they told me to take all of my teaching stuff to school so that they could take what used to be our schoolroom and make it into their man cave. So all the magnets are at school, and I'm not at school, and so I can't show you magnets. So what I want you to do right now, as soon as I get through saying this, is I want you to pause the video, go around your house and go find some magnets. So when I tell you about these things, you can try it, because I can't do it and show it to you because all my magnets are at school. They're in my stockroom in the big cabinet. So, yep, took them all to school. So pause it and go get your magnets. I'll wait. Okay, are you back? Got some magnets? Good. All right, let's talk about magnets. So, magnets are fun, aren't they? They're cool. So magnets, we've known about them a long time. There are naturally occurring magnetic rocks that people have known about for thousands of years, and which are cool. And they're called lodestones, is what they used to call them, their ancient name. Chinese people have been using them for things for a long, long time. And they're used now. We already talked about how magnets are used to produce electricity, because remember, moving magnets near a wire makes electricity, and that's how they make it. And you know, if you want to get a degree in any of this stuff, electricity, you can get a whole college degree in just this. So we're oversimplifying, because we have to at this point. You don't know enough, and we're just skimming the surface. That's what we do in high school, just to get you ready to go learn more about it in college. Okay, so magnets, let's talk about just in general magnets, the Earth size. Okay, first of all, the Earth itself has a magnetic north and a magnetic south pole, and that's why compasses will point north. Now, the other thing is, what about those lodestones? how that works is certain materials, certain elements that can be magnetic, their particles, while it's molten, these are metals, while they're molten, their particles all line up so that each particle that is magnetic, the north and south end of it line up, so then the whole thing becomes a magnet and acts together as a magnet. If that same metal is not magnetic, that means when it was molten and it cooled, that it was not in the presence of another magnet. So therefore, the particles will go every which way and they're not magnetic. But for the whole thing to be a magnet, all the little particles need to line up. And what causes them to line up is to be in the presence of another magnet when it cools. Okay, now this magnet that we've made by having the metal particles line up because of another magnet, it has a north and a south end. That's sort of like determined at random what is north and what is south. But then it is now what is attracted to the North Pole is the south end of a magnet. Because just like with electricity, opposites attract and likes repel. So with your magnets that you've gone and gathered, I want you to take 2 of them and try to stick them together. Either they'll stick real nice, meaning you have opposites that are attracting, or you'll get them closer and closer and they'll slide off to the side. Slide off to the side. That means you have likes that are repelling. So everybody give that a try. Turn your magnets over, shove them together. Okay, so that's your first thing I want you to see. The other thing is if you have a bar magnet and it has a north side and a south end and you break it in half, then this will become the new south end and that will become a new north end, and they'll still, each little half will have a north and a south. So that's kind of interesting, isn't it? Now, one of the things you can do, and you can see it in your book on page 495, is you can use a magnet with iron filings, and you can map the lines of magnetic field. The power of the magnet field, goes into all directions around it. And if you have a bar magnet, we have to pretend, because all my magnets are at school, then this magnetic field goes out the top and out the bottom, and it makes loops from the top to the bottom. Now, where you have done this, where you've actually messed with the magnetic field, is if you ever got the put the hair on Willie little thing at the gas station. You're on a road trip, your mom and dad want you to not fight with your brother on the long trip, and they'll buy you this little toy where it comes, you can get them at Cracker Barrel. You pull out the little magnetic wand and you shake the iron filings, and then you can put it underneath, and the iron filings are attracted to the magnet, and you can move around those iron filings. Well, if you had a bar magnet and put it under Willie, you would see the lines of the magnetic field. So that's pretty fun, and you can see that in your book. Okay, the next thing is the relationship between electricity and magnetism. And I told you that if you move a magnet near a wire, you get current. And it turns out that if you have a coil of wire with electricity going through it, then it becomes an electromagnet that can be turned on and off, and it can suck in a nail. So that's a little experiment you can do where you can, but you have to have a very, very fine gauge of wire with lots and lots and lots and lots and lots and lots and lots of coils. Usually when kids try to do this, their wire is not fine gauge enough and they don't have enough coils. But you can make an electromagnet. That could be your lab this week. You can mess with magnets. That could be your lab this week. So there's a thing called the right-hand rule, and it is used for a lot of things in science. But if you have electric current going through a wire, then there will be a magnetic field that will go around it in the direction of your fingers. So you can generate this magnetic field around the wire. And it only works with your right hand. It's the right-hand rule. So so you can make an electromagnet, and that's like what's used in junk cars when they pick up the car, they turn it on to pick up the car, they go over, they turn off the current, and it drops the car. So electromagnets are interesting. And in fact, my son Nathan, he was a chemistry major at West Georgia, and they were working on the world's smallest electromagnet, which was a 1 molecule big electromagnet. So that was kind of cool. I don't know how successful it was, but he was doing experiments for that. And now he's at Georgia Tech, and he has joined a lab group, but they haven't started yet because of COVID. Whoops, I got to touch your computer again because we got low battery. There we go. I'm putting fingerprints on your screen. Anyway, so in your book it showed you how the little particles line up. You can actually make something temporarily magnetic. If you take a magnet and you like stroke it down a needle over and over again, it will become a temporary magnet. You'll get the particles to line up enough, and then you can make a little compass by floating that needle like in some water, and it'll line up with the earth, with the North Pole, the magnetic North Pole, which has been moving. It's been moving lately, and they're afraid it's going to flip because according to the rocks, it's done that in the past, and they're afraid if it flips, that it'll fry all of our electric things, and that like it would cause chaos, world chaos. So there are people who are worried about this. I'm not too worried. I figure people have lived without electricity before, that we'll get by until we fix it. I lived through Y2K. So everybody was like, Y2K is coming, and all the computers are gonna break, and it's gonna be chaos, and planes are gonna fall out of the sky, and everybody's gonna die, and you better start stockpile food. And so like I bought some extra canned food at Sam's, and it was like, and I was pregnant with one of my kids. And so I was pregnant with one of my kids, and I was going into labor, and it was too early. So I was at the hospital, hooked up to all the beat machines, and they all said Y2K compliant because they had been checked, and all this money was spent to make sure Y2K didn't happen. And I'm watching the year 2000 rolling in from around the world, and they got it stopped. They gave me drugs, and they got labor stopped. So Eli didn't get to be born, you know, just as the year 2000 started, and babies who were born just then got like free college scholarships and diapers for life. Eli has earned his own free college scholarship, so he didn't need it. So that's good somebody else got that, not him, because he didn't need it. He earned it by him being a smart fella. But anyway, so, you know, the world was supposed to just go into a big old apocalypse, but instead the only thing I know that actually stopped working because of Y2K was we had a video camera, and it quit, and it would never work again. It was like the one thing that Y2K took out, boom, my video camera, which I had paid a lot of money for, so it was a little like, but you know, better than planes falling out of the sky. So I'm not too, because I lived through Y2K, and it was supposed to be the same sort of, everything's going to go bad. I'm like, I think I'll be okay. I'm not too worried about the magnet. There are things you can control and things you cannot. And in the magnetic pole flipping, we have no control over that, so we're not going to worry about it. Okay, our little electrical motor lab is a cool one if you can work that out, but don't have the stuff for that. Forces caused by magnetic fields, there is a relationship between the magnetic field, the current and force, and the length of the wire. So we'll be looking at a little bit of math with that in the math video. So come back to the math video and we'll talk about that and how electric motors work. I'll explain that in the math video too. They work with magnets. They turn on and off, and they push, 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 push it around in a circle. I just couldn't help myself. I had to go ahead and explain it to you. All right, so that is it for this class. Yay, we made it, woo, go us. Except we gotta come back for the math, and you gotta take the final test. And then you will have made it, yay, woo, go us. All right, so like, share, subscribe, come back and watch another class if you want to, or go on to college. Science is great.